Example 17, it says, find the volume of the solid formed when the region bounded by the curve y is equal to the square root of r squared minus x squared, and the line x is equal to minus r and x is equal to r, and the x-axis is rotated through 2 pi radians about the x-axis. All right, so we already established that the volume in such a rotation, v, would be equal to, all right, keep put it in the pi, let's put in the pi, the integral from minus r to r of y squared dx. Now, y is equal to the square root of r squared minus x squared. Now, if I square both sides, I'm going to get y squared is equal to r squared minus x squared. So let's plug this in. Now we have the volume V is equal to pi, the integral from minus r to r of y squared, which is r squared minus x squared. And of course, I'm integrating this with respect to x. Now, r is a constant. So if I integrate r squared with respect to x, I'm going to get r squared x minus x cubed divided by the new power, which is 3, and from the limits minus r to positive r. Now, this is pi. Next, I'm going to replace x with r. So this is r squared times r minus r cubed over 3. Then I'm going to replace x with minus r. So it's r squared times minus r minus r to the third power over 3. All right, and this would be equal to pi r squared times r is r cubed. So r cubed minus r cubed over 3 minus, over here we have minus r cubed plus r cubed over 3. So we have pi, then we have r cubed. Negative times a negative is a positive. So we have plus r cubed. Then we have minus r cubed over 3 minus, so that's minus r cubed over 3. So what we end up with is pi into 2r cubed minus 2r cubed over 3. All right, now 2r cubed is the same as saying 6r cubed over 3. So what we have is pi into 6r cubed over 3 minus 2r cubed over 3. And so our final answer is 6 minus 2 is 4. So it is 4 over 3 pi r cubed. All right, and this is cubic units. All right, let's have a look at another example. Example 18. Example 18 says determine the volume obtained when the straight line segment y is equal to 5 minus 4x line between x is equal to 0 and x is equal to 1 is rotated through 2 pi radians about the x-axis. All right, so the volume is equal to pi, the integral from x is equal to 0 to x is equal to 1 of y squared dx. Y is equal to 5 minus 2x. Sorry, that should be 4x. This is 4x. I'm going to square both sides. And so I'm going to have y squared. I could leave it. I could expand it if I want. I could leave it like that. Let's leave it like that and see how it works out. So now I have b is equal to pi, the integral from 0 to 1 of 5 minus 4x squared dx. Now, of course, when we're integrating a linear factor, we're going to increase the power by 1. So this is pi. Increase the power by 1. So this is 5 minus 4x to the third power. Then we need to divide by the new power, which is 3. And we have to also divide by the differential of the inside function, which is minus 4. All right. And the limits are from x is equal to 0 to x is equal to 1. 3 times 4 is 12. I can factor out that 12. So I have minus pi over 12. Factor that out. And we have 5 minus 4x cubed and from 0 to 1. So next I'm going to replace x with 1. And so I'm going to end up with 5 minus 4 times 1 cubed. Then I'm going to replace x with 0. So it's 5 minus 4 times 0 cubed. All right, let's keep going. So now inside we have to the left, this is minus pi over 4. And over here, this is 5 minus 4, which is 1. So this is 1 cubed minus 5 minus 0 minus 5 cubed. No, 5 cubed is 125. So this becomes minus pi over 4. 1 minus 125. All right, so we have now minus pi over 4 multiplied by minus 124. All right, 4, I think 4 into this is what? 1. 4 into this is 3, 31. A negative times a negative is a positive. So this comes out to be 31 pi cubic units. All right. Still time for another one. Example 19 says, determine the volume obtained when parts of the curve, the part of the curve y is equal to cos 2x, lying between x is equal to pi by 6 and x is equal to pi by 3, is rotated through 2 pi radians about the x-axis. Again, such a volume v is equal to pi, the integral from pi by 6 to pi by 3 of y squared dx. Now y is equal to cos 2x. If I square both sides, I'm going to get y squared is equal to cos square 2x. Now cos 4x would be equal to 2 cos squared 2x minus 1. And now we have 2 cos squared 2x would be equal to 1 plus cos 4x. Negative 1 goes over and becomes positive. Then if I divide both sides by 2, I'm going to get cos squared 2x is equal to 1/2 plus cos 4x over 2. And so volume V would be equal to pi, the integral from pi by 6 to pi by 3 of y squared, which is 1/2 plus cos 4x over 2 dx. I'm going to factor out the half. So this becomes 1/2 pi, the integral from pi by 6 to pi by 3 of 1 plus cos 4x dx. Now I'm ready to integrate. When I integrate, I'm going to get right about the 1/2 pi. If I integrate 1 with respect to x, I'm going to get x. Differentiate sine, I get cos. If I integrate cos, I'm going to get sine. So this is plus sine 4x. And of course, we have to divide by the differential of the inside function, which is 4. And this is for the limits pi by 6 to pi by 3. All right, so now I'm going to replace x with pi by 3. So I have 1/2 pi. Then I have pi by 3 plus the sine of 4 pi by 3 all over 4 minus, I'm going to replace x with pi by 6. So this is pi by 6 plus the sine of 4 times pi by 6 all over 4. This is 1/2 pi. Over here I have pi by 3 minus pi by 6. Now pi by 3 is 60. 4 times 60 is 240. The sine of 240 is the same as saying minus the sine of 60. So this is minus root 3 over 2 divided by 4 minus, all right, then, all right, negative times a positive is a negative. So that's minus pi by 3 is 30. 4 times 30 is 120. The sine of 120 is the same as the sine of 60. So that is root 3 over 2, and this is over 4. All right. So now I have 1/2 pi. This is 2 pi by 6, so this is pi by 6. This is minus 2 root 3 over 8. All right. And so our final answer is pi over 2 pi by 6 minus root 3 over 4 cubic units.